Hello everyone, I'm Vishesh Vaibhav, and today we are starting with GCCF infrastructure in Google Cloud. So this is going to be the module 2 of our Google Cloud Computing Foundations pathway, and I hope you must have watched the previous videos on the module 1 which Ayush uploaded, and also completed the practicals which we did in module 1. If you haven't done that, I seriously suggest you to do that first, because then you would be able to understand these videos really better. Next, so we are starting with a GCP Storage Services. So every application needs to store data, and every time everything that we do has to be stored somewhere. So where it is stored, so Google provides us with these storage types, and depending on the type of the data, depending on type of depending on our needs, everything is divided in these data sets, in data types, sorry. So if we have a data storage need which is in memory, so we use memory store, which is a function in Google Cloud given to us by Google Cloud. Then if we have a relational database, or if we have a NoSQL database, then we can use Cloud SQL and Cloud Spanner for relational, and we could use NoSQL for if we have a new NoSQL database, we can use Firestore and Cloud Bigtable for NoSQL database. I'll come to the difference between these in a while. If we have analytical needs, if we have a lot of data and then we need to do something on the data, then it's better that we use BigQuery for that. And if we have object like really unstructured data, we can just store it in the normal cloud storage, like we were creating buckets when we were uploading images or something. If we have block data, such as virtual machine files or things that we do on a virtual machine, anything related to that data is stored in persistent disk. So you might remember from the virtual machines we were creating, we were always storing data in persistent disk, 10 GB persistent disk, and as we go forward, we'll also be creating some virtual machines with something says 10 GB persistent disk or something like that. So it's totally fine if you don't know anything about this, but we'll come back to this so you understand everything. And for file, we have file store, like when we have lift shift apps, so which requires files, we can use the file store. So these are the things that Google provides us. So now, how do you choose your best storage option? How do you know that, okay, this storage option is better for me? Well, there are two types of data. There are structured and unstructured data. So if your data is structured, which means that first of all, we'll come to relational and non-relational just to understand it a little bit. So relational means data which is stored in tables, right? For example, some data, like we have done RDBMS in our courses. Like if you're from the ACET department or AIIT department, you might have a course that's called RDBMS, where we store data in some tables, which is called relational database, right? We created ER models and such, something like that. Now, NoSQL data is actually the opposite. The data is not structured, the data is just scattered, and we don't really know if that data is really, like, it's a lot of data and we haven't really structured it. It can be files, it can be reviews or something like that, but it's not really structured. So that's NoSQL data for you. Now, if the data is structured, and if there is a transactional workload, so that means we're using SQL, that is structured query language, for working on that data. So what does transactional workload and analytical workload really mean? Well, if you have a website, a dynamic website, and you want the data to dynamically appear as the user works on that website. For example, I'm signing into my website. I'm a user on a website, and then I'm signing in. Now I want, when I sign in, I want all of my data to be displayed. My public profile, my address, and everything that I have stored on your server needs to be displayed back to me. So that's called a transactional workload, because the workload is really dynamic and it needs to happen at a greater pace, right? So that's transactional workload for you. Now, analytical workload is when you need to actually do something with the data. You need to do some computations, you need to work on that data. So that means analytical workload. So then you need to work on that data, you need to compute something on the data, and that's called analytical workload. So transactional workload is again of two types, SQL and NoSQL. SQL as in structured query languages, the structured data, which means it is stored in tables, and then it is again divided into two things, that is local regional scalability or global scalability. So if that means that your users are in a local or a region, like a particular region like in Europe, or if the like customer base is expanded globally, you don't really know if you have a really scattered database of customers. That's global scalability. Now if you have a local and or a regional scalability, you can go for Cloud SQL. If you have a global scalability, you can go for Cloud Spanner. It really depends. Now if you have an analytical workload, again there are, okay, so now coming to the NoSQL part of transactional workload. So it might be that there are a lot of unstructured data, but then you want some dynamic things to happen with that data, but you want some you need to store that data somewhere. So you have Firestore for you. Firestore does the same thing as Cloud SQL and Cloud Spanner, but it stores unstructured data, NoSQL data for you. All right, and then comes the analytical workload. Well, again, something you need to do something on the data, then you can go for BigQuery. You can write queries and get something out of it. And NoSQL gives you Cloud Bigtable. So again, a lot of unstructured data put together. There are three common use cases for cloud storage. They are content storage and delivery, storage for data analytics and general compute, and backup and archival storage. So obviously content storage and delivery is a very like self-explanatory term. You understand what it does. But for example, if you want to do some data analytics on some big data, and you want to do some computations on that, so that's also a use case for cloud storage. You would need cloud storage for that. And for example, you have like disaster management setup for your website or your server. You need that backup or archive to be stored somewhere. So that's why you need cloud storage for. Now the difference between structured and unstructured data, as we talked about, this is really structured. If we want first name, last name, address, city and age, it can really be bifurcated easily. I want the age of Sherlock Holmes. Okay, the age is 60. So that's how you get that. It's very structured and it's really easy to find. Whereas unstructured data, it can be a lot of data, but it's not really structured. We don't really know what's coming next. So that's really unstructured for you. So it takes time. Now, which type of storage will meet my needs my best? So it actually depends. As we talked about, if my workload is transactional, I'll go for something such as like if my storage is transactional, I go for something like Cloud Spanner or Cloud SQL, right? And if my storage is if my needs are really analytical, I go for something like BigQuery. So it really depends on what thing you're going for. And there's this another term called horizontal scalability. Now there are two types of scalability. One is vertical scalability and one is horizontal scalability. Vertical scalability is when you are, let's start with horizontal scalability. It's really easy to understand. So let's go for an example. I have a server right now, and it was going really well. My business was going really well, but all of a sudden, the customer base that I had, it really increased. Many customers started joining my website and they wanted to explore it. So my users of the website increased. Now my previous server wasn't able to handle all of that. Now I need to scale. I need to expand my computational capacity, or the way I am storing the data of the customers, so that I can really accommodate all the new traffic coming in. So how do I do that? Well, there are two ways to do that. One is horizontal scalability, one is vertical scalability. Vertical scalability is when you add more to your, so I have a server right now, but when I add more RAM, more storage to it, it's called vertical scalability. I'm not removing the server, but I'm actually adding more things to it, more RAM or more computational power, right? But what is horizontal scalability? Horizontal scalability is when I already have a server, but now I am getting more servers like that to actually expand my workload. So to accommodate all the new traffic coming in, I'll just expand all the servers that I have. I'll get more servers, and that would distribute the workforce. So that's horizontal scalability for you, right? So now coming to REST API. First of all, what is API? What do we know about APIs? Well, API are application programming interface. I discussed that in a previous video. So just to put out in a simple way, a software needs to communicate with other software, right? If I write a code, I want it to be this way, that I want my code or I want my software to be communicating with other softwares. I want it to compatible with other softwares as well. So how do we do that? We do it with API. So we give it an interface and we give it a way so that my software can communicate with other software and the other software can communicate with my software. So it sets up something of a communication between those, and that happens through APIs, right? Now what's REST API? REST API is something that you'll be hearing a lot during your developer journey, and that is what REST API does for you. REST stands for representational API. API is application programming interface. So it gives us a few of its constraints. REST has some of its constraints that we need to fulfill in order to be RESTful. So all the services that comply with REST API, or the constraints that REST API sets forth, are called RESTful API, or called RESTful, sorry. So API sends these requests, right? Like I'm filling up a form and there is a website that needs to get my form. So what is the request that I'll be putting out? So all these requests are handled by APIs, like get, post, delete, these data requests that we sent out, these HTTP requests that we sent out is used to handle the data. So this is what it is. And obviously it is designed to formulate applications to communicate, and like all of these things, like these work great on cloud is because they are stateless, and authentication via OAuth and security by leveraging tokens. So OAuth is something of a like a security measure that we can authenticate via OAuth, and we'll be doing a lab on this, so you'll understand it better. Well, deploying and managing APIs can be difficult. Yes, it can be difficult. Like interface definition, authentication, authorization, management and scalability, logging and monitoring. Like one person cannot do it all, right? Well, how do we do it then? There are cloud endpoints. What are cloud endpoints? Well, these are distributed API management system which does all of these features that we talked about, like hosting, logging, anything that you can think of which you would be doing manually. But with these cloud endpoints, or APG that we're going to talk about, does this for us. So we can use it with any API that supports Open API specification, and it supports applications that are running in App Engine, Google Kubernetes Engine, Compute Engine, and clients include such as Android, iOS, and JavaScript, right? So what is APG API management? So it solves business problems like rate limiting, quotas, and analytics. And like obviously backend services for API management don't need to be in Google Cloud. You can get it from another like cloud provider. It does that as well. So APG API management is really good in terms of that, like getting third-party cloud services as well. Well, data ingestion is when stream data is received. So what is data ingestion? So there's some stream data coming in and it is ingested, it's taken in, and then there's some data pipeline, something happens with the data, and then some machine learning algorithms work on it and then gives us an output. Well, what is that, right? For example, you are booking an Uber and you are able to see the driver's location in real time. So how does it do that? Well, the taxi the driver is driving, the internet, the application that driver is using sends back locations of the driver every 30 seconds, so you can actually see it in real time. Well, now you understand that these Internet of Things applications receive these data very frequently, like very, very frequently. Now, if they are doing that, how can they not make mistakes while doing it? So these are the challenges. The data can be streamed from many different methods and devices. It is hard to distribute event messages to the right subscribers. How do we know that it's going to the right subscriber only? My driver's location is coming only to me and not the other way around. And data can arrive quickly and at high volumes, obviously, and it ensures services are reliable, secure, and perform as expected. Well, obviously, you want something like that from every service that you use. Well, there is a solution for these challenges is called PubSub. What is PubSub? So PubSub stands for Publisher Subscriber, and it is a distributed messaging messaging service. Now, what is that? Well, let me explain it to you by giving you a little bit of an info about it first, then the example. So a lot of data is coming in, and then you don't know how to really process it, who to send, who not to send, and this is handled by PubSub. PubSub handles that really well. So the data is ingested, and then PubSub reads it, stores and broadcasts it, and then it can be ingested, transformed and output, and a lot of things, and then can be visualized and explored using other Google technologies. So this is the PubSub architecture. PubSub helps us do that. So there is a topic, something called a topic in PubSub. So what is a topic? It is actually the central element of a PubSub. How do we know that which thing is this PubSub about? So this is what topics tell us. And topics and subscribers are decoupled, which means that I want to listen to a radio, and the radio wants to stream their, the thing they send out music, for example. They want to stream it to all those who want to listen to it. Well, if I don't listen to it, the radio will still keep running, and if I am listening to it, still it is running, and I can listen to more than one radios as well, right? So it means that there is one topic, which is the radio, and we are the subscribers to it, and even if I don't use that service, it's still there, right? So it just means that I can be a part of 0, 1 or more than one publishers, and the publishers can have subscribers which are 0, 1 or more. That really depends, right? So for example, human resources. So there was a new employee and a new contractor. They both came into a new company, a new organization, which came into the human resources topic. So this sends out notifications or messages to the directory service, facilities, system, account provision, badge activation. Now when they got that information, they can perform their own actions and see, okay, what needs to be done. Directory service needs to add them, facility system need to give them something, account provisioning should be done, badge activation should be done. So how do they know that? They shouldn't be informed individually, but they can be done through a PubSub example, through the human resources topic that we talked about. Now we come to GCP Security and IAM. What is this? So Google Cloud is designed with security in mind. And this is the shared responsibility that you need to be sharing with in order to use Google Cloud. So if you use an on-premises server, everything is yours, your responsibility. And then if you move out to different services, the responsibility of Google increases and yours decrease, right? Now we come to this. So data access is almost always the customer's responsibility. You handle who handles your data, who manages your data, right? So it is really your decision, your access, that your part, that who can access your website. So it's actually your part. So it's your responsibility to make sure the website is secure and things like that. And cloud identity and access management, IAM, which we'll be having labs on, lets admins authorize who can take action. So who would be doing what, can do what, and on which resource. So we can definitely do that. And also IAM policies can apply to any 4 types of user sources, like Google account, service account, Google groups, cloud identity, Google Works admins, workspace domain. So you would understand this when we be doing these, creating these policies and doing these labs. So it'd be a lot much understood to you, right? And there are 3 types of IAM rules. They're basic, predefined, and custom. And custom is a lot more, gives you a lot more freedom to give those roles up. And IAM predefined rules apply to particular Google Cloud service in a project. So there's a project, and we'll be seeing one diagram which tells us how the hierarchy of the policies go, of the roles go. So who can do what on compute engine resources in the project or folder organizations. We're now really predefining and giving it a more narrow way of giving those information out, giving those roles out. And the roles can be only applied to the project level and not the folder level. So I hope you understand that. Now IAM predefined roles can offer more fine-grained permissions of particular services, like this. So instance admin role can compute, can delete, can get, can set machine can start or stop. For same custom rules can, like, this gives you a predefined rules. So these are the predefined rules of an instance admin role. Now when it comes to custom, when we come to custom roles, we can really customize it according to our need, and that's something that we can do. Now service accounts control server to software interactions. So service accounts is something that we'll be creating in one of our labs. So this is how you identify an email address that is a service account. So there is that, and you don't need to worry much about service account, but that comes up when you are working a lot on the projects. So policies are applied to an organization, then it is applied to it is inherited from the organization to different projects, and then these resources inherit from the projects, just like that. So that's how you know. And you leverage and understand the resource hierarchy. So you can use projects to grab resources. You can check the policy granted on each resource. You can use principle of least privilege, which makes sure that the least privilege is given to every other role that you create, and then you can customize it using the custom roles according to you. Audit policies using cloud audit logs, and audit memberships of groups using in-use policies. So I hope you understand. And network admin group can definitely grant roles. So for example, if I am creating a role, there is a person who only needs to see it, and there's a person who needs to read it and see it as well, create it and see it as well. So that's what it is done here. Now these are some best practices that you should be using while creating a service account. So with this, we come to an end of module 2 practical video, but then we'll be starting with the theory video. We have ended the theory video. Now we'll be starting with the practical video from the next one. So I hope you are excited for that, and once that comes out, I'll be sending out a message on the group. So thank you so much and have a great day.